Hello there, Southwoods Math students. This is Mrs. Lindsay, here to talk to you about translating parabolas and using some transformation notation. We like to call this parabolas on the move. I'm going to talk to you today primarily about parabolas and primarily about translating. So let's get to the first slide. So what happened to the parabola f of x? So what we're going to do is talk about f of x as our primary parabola. You can see the vertex is at 0, 0, and you can see it's a parabola. So it's in the x squared family, the quadratic family, but it's not just f of x equals x squared because it seems to be stretched. Instead of going over 1, up 1 to the surrounding point, it's going over 1, up 2. So it seems to be stretched by 2. So that tells me f of x is going to equal 2x squared. Now g of x is the exact same parabola. It's going to have a lead coefficient of 2. But the vertex has been moved. Instead of 0, 0, the vertex slid to the right 2 and up 1. So the new vertex for g of x is going to be 2, 1. How would we write the equation of g of x? Well, we take the original x position from 0, 0. We move it 2 places, 2 units to the right. And since inside is opposite, that would be x minus 2. Square that. And then the outside is the y coordinate. And that is the same sign, or the outside tells the truth. So our equation g of x equals 2 times x minus 2 squared plus 1. Now, important, what happened to the vertex of f of x? All right, it was a horizontal shift. We shifted it right 2. There was also a vertical shift. We shifted up 1. Now, when we talk about function notation, or translation notation, this can be any function. We don't have to worry about the x squared because we don't have to worry about the quadratic family. So we're not worried about x squared. We're just talking about the new function g of x and how it moved from the original function f of x. So if it moved to the right 2, that means on the inside we have minus 2. And if it moved up 1, that means on the outside we have 1. Notice how there's no x squared. We're not worried about this being a quadratic function. It could be any function, okay? It's just f of x being translated 2 units to the right and 1 unit up to become the new function g of x. Let's look at the next slide. On the next slide, we have 2 more parabolas. Now these parabolas are concave down. First thing is what we notice. And the second thing we notice is we're looking for how k of x translates to become j of x. So my primary function here is k of x. So I'm going to look right away for the vertex of k of x. So my vertex for k of x seems to be negative 1.5, if you look closely at your slide, comma 7. Right? And now where does that move? It seemed to move to the right and down. So my vertex of j of x is positive 4.5, again if you look closely, comma 3. Now, let's not worry about them being parabolas. Let's not worry about them being concave down. Let's just talk about what happened, right? How did j of x come to be from k of x? Well, how far did my x move? Well, if we count the units from negative 1.5 to positive 4.5, I get 6. And that's 6 units to the right. So we'll call that negative 6. And how did the vertex move down? Well, it seemed to move down from 7 to 3, so that would be a -4. So J of x was created from K of x by a movement of 6 units to the right and 4 units down. Now we can make the equations. The equation of K of x we can get straight from the vertex, but remember that it's concave down. So that would be negative x plus 1.5. And now we write squared because now we're talking about the equation of a parabola concave down, and plus 7. All right? So remember, the inside is the opposite of the x-coordinate of the vertex. Now J of x, really, if you remember that it's moved to the right 6, we can subtract 6 from 1.5, and we kind of don't even need to look at the vertex. We can just look at the translation, and then plus 3, because we came down 4. We lost 4 from the 7. So if you see, we can actually add in the -6 to the x shift and the -4 to the y shift. We don't really even need to look at the graph. So on the next slide, we don't even have a graph. So let's talk about the function f of x as x minus 1 squared plus 2. We have an equation. Now, we're giving you pretty much the directions of the new function g of x, and all you need to do is write the equation. Well, which way did it shift? The -6 tells me that it shifted left 6, because the inside is the opposite. And the 1 tells me that it shifted up 1. But we don't need the graph to write the equation. All we need to do is add 6 to the -1 that went with f of x. So now we have x plus 5 squared, and add 1 to the 2 plus 3. Well, we can check to see if that equation is correct, because if that equation is correct, the new vertex should be -5, positive 3. So if we check on Desmos, we have f of x and g of x, all right? And one, 2 for f of x, and -5, positive 3 for g of x. Okay, it's your turn. If you see f of x and g of x on number 1, which is your turn, you can write the equations. You can tell us, was there a horizontal shift? There doesn't seem to be a vertical shift, so that might be 0. Don't let that throw you off. You can either add 0 or you can just leave that blank. So this is Mrs. Lindsay. Until tomorrow, signing off. Good luck.